Hello again, friends. If you follow my YouTube channel, you know that I've embarked on a very ambitious project to attempt to get 3 different radios, 1 SINCGARS ASIP and 2 Spearhead handheld radios, reporting their GPS positions to each other. We've already posted the first video in the series on YouTube, so be sure to check that out if you haven't seen it. In this series of videos, we're going to attempt several things. First, we want to get all 3 radios configured and interoperating for situational awareness. Once that's done, we want to get all radios to be displayed on a graphical map on the enhanced control display unit display, shown here in the middle black handheld device. And then third, we want to do some troop movement simulation, where essentially I walk around the neighborhood with a radio, so you can see that the map updates in pretty much real time. The overall project is much too long for a single video, so I had to split it up into 4 videos, into 4 parts. Here's an overview of what you can expect in the overall series. The first video has already been published and briefly goes over the project and shows the hardware and how it's all set up. This video, which is the second video in the series, will go over how to configure the SINCGARS RT-1702 ASIP radio. It will also show the enhanced display unit showing a map of the location of where this radio is in my neighborhood. The third video, which should be posted about a week after this one, shows how to configure the Spearhead radios, the handheld radios, and I show how I've placed them in different parts of my property. And it will also show these 2 radios displayed on the enhanced display map of the 1702 SINCGARS radio. In the 4th and final, hopefully final video, we'll do the simulation of troop movement. That is, if you can consider me walking around my block as a troop movement simulation. Okay, so how do we set up the system for situational awareness? There are 3 main steps, and I'm going to go over each one very briefly here. You'll see them in detail in the video. So the first step, which is actually not shown in the video at all, is you have to determine the area or areas of operation. And once you've done that, you've got to create a mapping file in I'm using a CIB format file, which is a graphic mapping format. But I believe that there are other formats that can be used. I believe there's one called CAD-RG, which I think will handle color. And you've got to have some way to create these mapping files. And this is a massive component of the project that I'm not going to be able to get into. And I just know the very most basics about it, and you can see the results of how little I know when we get to show the maps. And then what you've got to do is load those mapping files onto the display unit. And here, you can see the display unit. Now, the way that this is loaded requires software on a PC. It requires cable to connect to the display unit, and of course, display unit, and it's a whole process. But anyway, this is a very big part of the whole process, but too big to show in these videos. The second step to get situational awareness set up is, of course, get all the hardware set up. Install all the antennas, both the VHF or UHF antennas, get the GPS antennas set up if they need to be, install batteries, install microphones, all of that. And the third step is to go through and configure each radio. And there are certain details that each radio needs to be configured with. So the first is the combat ID or CID. Each radio has to have a unique number within that network. They have to all be configured with the same hop set, and we go into this a little bit more detail later on. But a hop set is a list of frequencies because these radios can only do this situational awareness using frequency hopping. In our case, we're using a hop set called F100, which is a standard hop set in these radios. All radios need to have the same ciphertext key details. Again, this is not something I'm going to go into at all in this series of videos. And then finally, we have to enable the GPS capability on each radio, and then further enable the situational awareness capability of each radio. Well, you've all been waiting very patiently, and I appreciate that, so let's get right into it. This video starts where the last one left off. The last one left off, we've already assembled all of the hardware, and here we are getting ready to configure the SINCGARS radio. Okay, so now that the hardware has been all set up, I'm going to show you the loading first, the configuration of the 1702, which is the SINCGARS, the ASIP product. And right now it's off, and I've got this flash on. Hopefully this flash is useful to the overall picture. Okay, so the first thing we do is we normally put it in test mode, but I know it passes that test, so let's just put it on, squelch on. Okay. All right, and I'll also zoom out a little bit so you can see on the right what the display does here. Alright, so now if you'll notice on the top of this display here, it says radio interface disabled. And that's normal. What that means is there are some functions available to you and some functions that are not. And so the reason this says radio interface disabled is because here, I don't know if you can see that. Let's focus that in. This has got to be set to remote. Well, you really can't see that, but there's a remote function, and then you will get all the capabilities on this remote control display unit. I believe that's what it's called, CDU, control display unit. Okay, so let's do the first thing. So we went over this before. The first thing we want to do, let's just zoom in a little here, get the best experience possible, is, so what your first thing you'll notice is, let's look at what the display here says. So low, we are in low power mode. I may change that once I take the radios out of the house to do some longer distance testing. But right now it's in low power mode. You'll also see the mode is FH, which is frequency hopping. We're in channel 1, and we are in ciphertext mode. What's blocked out here next to it is PT, or plain text mode, and that's for various reasons, which we'll get into. And then what frequency, what is in channel 1? Well, channel 1 has F100. What is F100? F100 is a frequency hopping hop set, and it's a list of frequencies that the radio can use to transmit on, and it uses all of them in a very rapid, in fact, don't quote me on this, I think it's like 10 hops per second, might even be more than that. I guess I should really have looked that up before I did the video. And so let's just, for the sake of argument, saying it's doing 10 hops per second. It's going to use all of the frequencies in that hop set in a pseudo-random fashion. It's going to seem random, of course, to the enemy, but given data from GPS, which sort of sets the time, the current time, some built-in cipher material, key material that's built into the radio by default, because based on what country code the radio is programmed for. Every country will have its own code when these radios are manufactured, and that is also part of the key material that's used to create the cipher, and then which of course drives the pseudo-randomness of the frequencies selected on at any given time. And as long as all the radios you have are from the same country, use the same hop set, and all have the same GPS world time, essentially, they should hop to the same frequency at the same time. Just a quick word on cryptography and frequency hopping. So just so everyone's clear, these radios use NATO encryption, which is commercial off-the-shelf products, and therefore do not contain any U.S. military cryptography. This is important for everyone to know. The topic of cryptography when it comes to radios is a massive topic of which many volumes have been written on and can be written on, but it includes subtopics such as electronic countermeasures, which an example of which would be jamming. In our case, frequency hopping falls under a category called electronic countermeasures, meaning that we are by hopping the frequency, it makes the transmission more resilient against something like jamming. And then ComSec, which is encrypting the data or communications as it flows. Anyway, very complex subject, and what we're showing here is just a very simplistic approach, relying on a lot of default configurations, relying on time syncing using GPS, looking at common security codes, and we're not using any user-specific security codes, and we're using the default, country security codes, which are built into the radios. Okay. So now that was a brief explanation of that. Well, now what do we have to do to get this set up? So as we discussed earlier, the first thing is we have three things we have to do here. One is load the combat ID. Every radio needs a unique combat ID so you can tell who is who. Two, we've got to enable the GPS, and the GPS will take some time to warm up and lock. And three, we have to enable the situational awareness. The situational awareness essentially tells the radio to transmit I think it's every 2 minutes, to transmit the radio's location, and then so other radios listening using that same hop set and in the same net will all get the positions of all other radios. Okay, so let's go ahead and do the first part of this. Now, to make these modifications, these config modifications that I just spoke about, we've got to put the radio in load mode. Right now it's on. We're going to rotate it down. I'm not sure you can see that, to LD. Okay, and now we can begin. So the first thing we want to do is set the combat ID. And so the way we do that is we press 8, which is the CID here. Let's just see if I can zoom in just a hair more. All right, and let's see if it'll focus. Okay. So 8 is CID, it's the combat ID, we press that. And it says no ID set, so let's set it, I think you hit it again. Oh wait, what now you do is you clear it. And you put it in. And so for this one, we're just going to use 0, 0, 0, 0, 1 and store. Okay, so the combat ID has been stored. Okay, so the next thing we have to do is set the GPS, and we press this number 5, GPS, we press it, and then we hit change 7. Okay, now it's in auto. Let's cycle through the options here. Off, auto minus, I'll explain that, and manual minus. What we want is auto. Now what the minus means is that the GPS is enabled, but the GPS card inside has not yet locked onto the GPS, has not created a fix for the GPS. And that'll take some time. Okay, that's done, and now the third thing we have to do is to enable the situational awareness, which is here, number 6, which is off. We go to change, and we set it on. Again, on, off, on. You'll see the minus again is reminding you that the GPS is not yet done. So hit store. Oh, I guess we just wait a second for it to time out. I think this is okay. Okay, now let's go back to on. All right, so this is squelch is on. Let's go back to load one more time and just see that we've loaded everything. Now, we won't be able to get the combat ID out, I don't believe, but we can check the GPS. Good. And we can check the situational awareness. On. Okay. So everything should be now how we need it. Now, the F100 is just a default hop set, and it's standard. So on SINCGARS machines, SINCGARS radios, F100 is a specific hop set, and in this case, I think it covers all 1 megahertz frequencies between 30 and 88. So it has 30, 31, 32, 33, all the way up to 88, and it will use all of those to hop against, as I mentioned earlier. All right, so now let's take a look again. This part is done. That was, I will mention one other thing about the hop set. So you can define the hop set. First of all, it's got many different hop sets built in, and I'll show. It's easier to show on the Spearhead radios. I'll show you that. But there's something like 5 or 6 different built-in hop sets, all of which have a different list of frequencies involved. With software. And with the proper software and the right cable to communicate with the radio, between the PC and the radio, you can create your own hop sets. And in fact, you could also create hop sets that are broad and put in exclusion frequencies. I forget what they call them exactly. But you'll say, okay, 30 to 88, but I don't want between 37 and 57, for example. You can block out that, and it'll use the frequencies surrounding that. So why is this interesting? So for ham use, we would want to create a hop set that is 50 to 54 megahertz, because that's the 6-meter ham band. And that's something that I'll work on in the future, but it's complicated enough to get this working. Okay, so we're back to looking at the display here, the enhanced control display unit. And let's see, again, it says radio interface device disabled. Now, in order to enable it, I mentioned earlier, we've got to rotate this switch here to remote. And you'll watch what happens here. And so now you'll notice there's more information on the top here. It's telling you what hop set you're using, F100. I think you can see that. It's telling you channel 1, power is low, ciphertext, and frequency hopping. GPS, what's it say? Auto, at the top you can see auto, but it's still not, has not gotten a lock yet. SA is on. Let's see, can I get the combat ID? CID. No, it doesn't show it for some reason. Okay. Now let's take a look at the navigation in the RT display here. Okay, so this stuff is not yet available. It says GPS is off. All right, let's give this a minute to get a lock, and we'll see what happens. Okay, so about an hour has passed since that last clip, and the reason is I was having the hardest time getting the GPS part of the 1702 to work. And I really thought, because I'm just new to all of this, I really thought it was something that I'd done wrong and that my configuration wasn't right. And I spent the last hour going over it and over it and over and over it. I could not find the problem. And then it kind of dawned on me that in my kitchen, I may not be able to get good GPS reception. And so I brought the radio outside into my front yard. And sure enough, now this is what I was hoping to show, you know, about an hour ago. Okay, so what do we have on this display? Now, I'm not 100% familiar with all of it. And just remember, this is the main display, and I'm going to the navigation RT display. So my GPS coordinates, something 238 east, 5161.8 north. I've got a little reading up to do on my GPS. I would have thought it would be west, not east, because I am in the Western Hemisphere, but what do I know? AT&T XL, don't know exactly what that stuff means. Plus 109 meters. I believe this is my height above sea level, which would make sense. I'm about 350 to 400 feet at my house, something in that neighborhood. And then the 3 with the circle in it, I believe, indicates I'm locked onto 3 satellites at the moment. Okay, just a word on this GPS stuff. Clearly I did not do my homework before making the video, so here's a little post-production edit. The GPS and position reporting used by the SINCGARS systems and many other military radio systems does not use latitude and longitude as I had assumed. Instead, I've learned that it uses a system called MGRS, which is the Military Grid Reference System. MGRS is a grid square system used by NATO and the U.S. military. The format of this system is 2 characters, 2 characters, and then between 1 and 5 numbers, quote-unquote, easting, and 1 and 5 numbers, northing. There is no westing, there is no southing. I will leave some links in the doodly-doo about this system from Wikipedia and other sources. So here is just an example of how the grid system works. There's the first two characters indicate a square on the globe of 6 degrees by 8 degrees in most cases. Then there's another 2 characters which gives a 100-kilometer square within that 6 to 8 degrees. And then depending on how many digits easting and northing, you can get a precision of down to 1 single meter if you look at the bottom here. And that uses 5 characters by 5 characters. And if you'll notice on the control display, we are getting 5 characters by 5 characters. So the idea here is that you should be able to detect movement on a map in this system to the resolution of 1 meter. So here's an example of what we actually see on the enhanced control display unit. And you'll remember this from the video. So we had this number AT&T and followed by XL. And if you look at this grid square layout, AT&T points over to this rectangular section. I've circled the AT&T in the center of it. And then within it, there's this XL, which is the second 2 characters. And you can also see a little square section called XL. And in fact, that is the rough area of New York that I live. And then we've got a 5-digit 00258 easting and a 5-digit 54652 northing. Given that those are 5-digit numbers, that would indicate again a resolution down to 1 square meter. So that's how this system works. Now, so the top portion here is my local position, and then here are any reports, situational awareness reports from other radios. But right now, I have not yet configured the other 2 radios, which we're going to do that. We're going to do that post haste. Oops. There's one other thing, but now that I want to show here, because now that we've got our own GPS fix, what we can do is we could look at the map display, and I hope this comes out. Okay, it's kind of hard to see. I'm going to zoom in. I'll cut in some pictures of this. But there's my house, that little white. This is a grayscale image, and I have been told by those in the know that I can install higher quality color images. For example, there may be a way to export sections of Google Earth, export them into the CIB format, which I talked about earlier, and therefore have a better display here. But I don't know if you can see all of this, but here it's giving me my details. And then up top, if you can see this, I don't know if you can, 23 meters. So that's the scale. If I increase, so I use the up button of the 5-way thing here, I increase it, you can see I'm zoomed in. And as I zoom in, this changes. So for example, at this level of zoom, it says I'm at 11 meter. I could zoom in further, and that's 6 meter. And I'm not sure if you're getting all this. Take my word for it. And so, for example, we're back to a 23 meter scale. Now, what you'll notice, hopefully, if this is coming through, is a blue dot. The blue dot is right there. That blue dot indicates where where this radio is, the local radio is in comparison, well, on the projection of the Earth and the map data that's been loaded here. And so you can see, even though I'm on my front porch, it's showing me a little bit off my front porch. Now that could be for various reasons. One, I may not have a great fix on the GPS coordinates. That fix may be improving over time, especially if I can get another satellite. It could be that the map is off a little, and you can even see that it moves around a bit. So I'm a little further away from the house now than I was a second ago. And so, but this is the really cool part. And now you could really zoom out a lot too. So I really don't know if this is all coming out. That's like my neighborhood. This is my town, my village. And you could really zoom in and out. You can see a lot of the trees. I'm not sure if it's visible, but we've got a lot of trees in the area. And that's zoomed in quite a bit. That's the front of my house. I'll show what Google shows my house looks like from this angle. Oops. All right, so that's for starters. Things are working well now. The next thing we have to do is get the other 2 Spearhead radios set up and then reporting their position, and we should be able to see them. Now, what you'll see is my position, the SINCGARS, the ASIP radio here, is a circle, and the other radios will show up as blue squares. Now, you remember, you've probably seen on eBay or read about this product, this computerized battle management system called Blue Force Tracker, BFT. Blue Force Tracker is a battle management system that all of this stuff could feed into if you had one of those systems. And blue are the friendly troops, and red or some other color, I'm not sure which, would be the enemy positions to the extent that they could be reported. But the Blue Force Tracker shows, that's why the dots are in blue.
Just a little word on the maps. I have very little experience in generating the maps that can be used for the system. However, I am assured by others that maps can be generated and can look much better than what you see here. I use the CIB map format, which I exported from other GIS data sources. And this CIB map format is a grayscale file format. I'm told that the display unit will accept other file formats. My understanding, although limited, is that a format called CAD-RG might be a color format. Also, the resolution and zooming capabilities should be improvable by exporting the proper scale tiles and using a good source of satellite imagery. There's a ton more work to be done in here and a lot more learning, but I just wanted to give you a little update that this actually can probably be made to look better than what you see here. Okay, that concludes part 2 of this series. Be sure to tune in next week when we show the configuration of the Spearhead radios, and we get them to also show up to report their position and show up on the mapping display. See you then.